Hello everyone, this is the end of our laboratories. Actually, this is the course project, and uh, the professors asked us one day to present and to choose from this list of the topics. And I have actually chosen the group one, which is the networking fundamentals, network types and topologies, and network models. So I'm going to explain with you further about this topics. So I'm going to discuss with you first the first topic, which is the networking fundamentals or network fundamentals. Okay, back in the day, computers have no means to connect and transfer data from one computer to another, but recent advancement in technology has made computers to do so. A network is a group of two or more computer systems and other devices. Those are connected to share and collect data with a purpose. In the modern computing infrastructure, the integral part is computer networking. So this is the computer networks. A computer network is a set of computers connected together for the purpose of sharing resources. It is a collection of computing devices that are connected in various ways in order to communicate using electronic means. Connection between computers in a network are made using physical wires or cables, but through network connection. So computers are able to share file, internet access, printers, and so much more. So, but nowadays it can be connected using wireless, means using radio waves or infrared signal. So this is an example of a sample or of a simple computer network. Here it is. So it has been like connected to each other, the computers, the personal computers. They use the cable, which we mentioned earlier, and the printers. But as I have told earlier as well, that we can connect all of them with a wireless now, okay, or a Bluetooth, like that, because of this advancement in our technology. So we'll proceed now. So we have these components of the network. So the computers connected through either the use of Ethernet cables or through wireless connection. That's what we mentioned earlier. Devices like we have a lot of a lot of end devices that could be used, or let's say components of the network. So here it is, end devices. We have the laptop. We have the smartphone, which is very popular nowadays. We have also this personal computer. We have printer. We have printer. We have printer, and we have a camera. Okay, so also we have this intermediary devices. We have these hubs or hub. That is a device connecting multiple computers together and makes them perform the functions as a single unit. Okay, next we have a switch. Switch, this is a computer networking device that connects devices together on a network. The next one, we have here the routers. Okay, these are small electronic devices that join multiple computers together via either wired or wireless connection. The next one we have is a network card, or also known as network interface card, or NICs. Or these are hardware device that connect a computer with a network. And this is a modem. This is a device or program that enables a computer to transmit data over, for example, a telephone or a cable lines. Okay, so we have also the applications that uses a network. One of it is the games, the databases, the email, the video conferencing, and the file transfer. Oh, let me just remove again. I'll remove this one. Okay, file transfer protocol, or the FTF. Okay, so games. This one, the games are, allows multiplayer games between various devices. The databases as well is a networking. Networking makes it possible for different computers. Now let's proceed with our second topic, which is the network types and topologies. Okay, so we have to discuss the three basic types of network. We have here the LAN, or the local area network. The connection would look like this. Okay, this is the LAN, one of the basic types of network. Second one is the wide area network, or WAN. Okay, this one, a network. Let's just go back first with our LAN or LAN. LAN is this is an individual network that usually spans a single geographical area, providing services and application to people within a common organizational structure, such as a single business, campus, or region. Okay, a common LAN devices are switches, hubs, and routers. So as I have told earlier, or I have shown earlier, this would looks like, or if you're gonna configure the LAN or gonna use the network LAN, then this would be your it looks like the connection would look like this. Sorry. Okay, so let's proceed with our second one, which is the wide area network or WAN. So a WAN is a network connection between two or more LAN, okay, over a potentially large geographical distance. Often, one particular node or on a LAN is set up to serve as a gateway to handle all communication going between that LAN and other networks. So communication between networks is called internet or internet working. But the internet is the best example of WAN. So if you have one, it would be looks like this. Okay, so the one would cover a big or a large or a wide area. Okay, so it could be covered wide area. Okay, then we'll proceed to the next one, the last but not the least, which is the metropolitan area network or MAN. A MAN is usually interconnects a number of LANs using a high capacity backbone technology, such as fiber optical links, and provides uplink for services to ones and the internet. A MAN's coverage can span between cities. So MAN, it's only between cities. But you can, yeah, I'm gonna show you how it looks like. Yeah, the connection of a MAN. Okay, so it's so those are our three basic networks. So we have also here the client server model. So the client server model is a servers have software installed that enables them to provide information and services like email or web pages to other hosts on the network. Clients have software installed that enables them to request and display the information obtained from the server. So the relationship between clients and server is known as the client server model. So it would be look like this. Okay, so we have here the server. Can I annotate? Just 1 minute. I'm gonna try to annotate it. Okay. Spotlight. So that is the server. So this is the internet, and then it will go or so I'm gonna stop it. Okay. This is our server, which will get the information from here, and then it will pass here using the internet, and then it will go to our client. Okay, this is our client. Okay, okay then. Clear all drawings. Okay, so let's proceed. Oh, clear all drawings. Okay, and then okay. Okay, then let's proceed. Okay, so network, let's proceed with our network design or topology. So in bus topology, we have bus topology. I'm going to show you later how it looks like and how we're going to connect us topologies, okay, from the bus topologies, because I have saved all the laboratories that we have done earlier, okay, all the laboratories, the bus topologies, how we are going to connect it, using our Cisco packet tracer, the others. So I will just gonna walk you through and we'll show you how it looks like. Okay, so for now, I'm gonna just give you a bit information about the bus topology and the other topologies. Okay, so bus topology is a network topology in which every computer and network device is connected to single cable. So that's only a single cable, which I'm gonna show you later. Okay, so we have also here the we have also here the mesh topology and also the ring topology. The ring topology is a topology that forms a ring. So by the name itself, it's a ring, so it's a circle. So as each computer is connected to another computer, okay, so it will connect like a round one or a ring one. Okay, later I will show you as well. Okay, so the next one is the star topology. This is a type of topology that computers are connected to single hub through cable. This mesh topology actually it's like a complicated one. It's a lot of connection that it's not it's look like a I don't know how to explain that, but it's very complicated or you'll see like a but it is good that I'm gonna I mean I'll show you later so that you would understand how, for me, how complicated it is. So the next one is the hybrid topology. The hybrid topology actually is a topology that um, the combination of two, like the star topology, image topology, you will combine it. That would be a hybrid one. Ring topology and the star topology, you will combine it together. It would be a hybrid topology. Bus topology and ring topology, we combine it. Hybrid topology, that equals to hybrid topology. Okay, let's proceed with our network and communications. So, okay, the protocols. Protocols are the rules that govern communications. It is made up of a group of related protocols that are necessary to communicate via electronic means. So network protocols, it's networking protocols, describe processes such as the format or structures of the message, the process by which networking devices share information about pathways with other networks, how and when error and system messages are passed between devices, and the setup and termination of data transfer sessions. So that would be, I mean, it would be look like that. Okay, for the network protocols and communications. Okay, we have ISP here. We have router here. We have these devices and the server. So protocol suites and standards. Okay. So we have here the protocol suites and the standards. So can you just put it here? Okay then. So we have here actually the protocol suites and standards. It's like governed by an organization such as IEEE, Electrical and Electronics Engineers, and IETF, which is Internet Engineering Task Force. So they are the one who is like governing this protocols and standards. Okay, so here we have the hypertext or hypertext transfer protocol. This HTTP, it is a common protocol that governs interaction between web server and a web client. So we have here the hypertext transfer protocols, or the HTTP, which is it is a common protocol that governs interaction between web server and the web client. So it also defines the content and formatting of the requests and responses between the client and the server, where both the client and the web server software implement the HTTP application. HTTP relies on other protocols to govern how the messages are transported between the client and the server. So the next one is we have the transmission control protocol, or TCP. So transport protocol handles the individual conversation between servers and clients, and not just web servers and web clients, but also the TCP segregates the HTTP messages into smaller pieces called segments. It is also responsible for controlling the information exchange between the server and the client, such as the size of data, the flow control on how much is sent and received, and the reliability on which the sequence numbers are monitored in case of lost or missing something. The next one we have is the Internet Protocol, or IP. So it transferred the formatted segments from TCP, encapsulating them into packets, and designates the appropriate source and destination addresses from the original source address of host to the final destination address of host. It is used by routers in selecting the best path to the destination host. Lastly is the multiple protocols. The message received by the host usually lastly is the multiple protocols. Okay, the message received by the host usually contains multiple protocols plus the actual data, which the application header may or may not exist. So let's proceed to the encapsulation and decapsulation. So encapsulation, this is a process to hide or protect a process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. It's like, encapsulation is like a code that if the outsider sees this, they will not understand. Okay, so that's why or even the client or the receiver of this code couldn't understand. He have or she has to encapsulate this code. That's the work of, or that's the work of decapsulation. Okay, so to decode. So as I have told you, the decapsulation is the inverse of the encapsulation process. So encapsulation is the process of wrapping a data. To make it simple, it's like a code, okay? A code. So like, for example, the code like A, B, C, D, E, F, G, okay? It's just like a sample one, but the encapsulation will decode that one, okay? So it would be like this. Okay, so the encapsulation, service source, and the host, like that, okay? So the host of this, or the receiver of that message or code would understand after decapsulation. Okay. So let's proceed to our third topic, which expand a little bit. Okay. So show you that the different model. Okay, network models. We have protocol model, we have reference model, and the network models. Yeah, it's the network models. Okay, so this is it. This is the TCP model. Okay, this is the network model set. We're gonna discuss this later. Okay, later. I mean, yes. OSI model. OSI stands for Open Systems Interconnect. This is a system that breaks down network function. This is the most popular type of internetwork reference model. Consists of 7 layers. So that's why physical, data link, network, transport, session, presentation, application. Uh, those are the layers for OSI model. And for the TCP or IP model, it stands for Transmission Control Protocol, or IP, or I mean, for IP, it's Internet Protocol. So also known as the Department of Defense, or DoD model. This is the protocol that is used in the internet. So as mentioned above, okay, the OSI model is a network model widely used today. This section discuss, or so let's just proceed with the application layer of the OSI. This application layer will start with in the seventh layer, layer 7. Sorry, we will start in the layer 7. So in OSI model, so the application layer. Okay, the application layer is the topmost layer of the OSI model. This layer provides a means for the user to interact with the software application. Everything at this layer is application specific. This layer provides application services such as file transfers, email, and other network software services. So the second layer is the presentation layer. This layer provides proper common data format that is sent across application layer services. The next one is the session layer, which is the layer 5. This application establishes, manages, and terminates connections between applications. This layer provides services to the presentation layer. So as you can see, it's really, the function of each one is depending on the other one. Okay, so see the application. The application is, it's just depending on the presentation. Okay, the data that has sent by a presentation to the application. So in order for the application to do his work, he needs to have the data from the presentations, and presentation as well. It's waiting for the session layer to send them as well, the data, or yeah, the service, because it says that the session layer is the one who provides services to the presentation layer. So let's proceed with the layer 4, which is the transport layer. So this layer defines services to segment, transfer, and reassemble data, and reassemble data, individual communication between the end devices. This layer basically describes how data is sent across the network. So the next one is the network layer. This layer provides services to exchange the individual pieces of data over the network between identified network devices. The layer two is the data link layer. This layer provides methods for exchanging data over a common media. So, and the last but not the least is the layer one, the physical. It's also an important part, very important part as well of this model, the physical layer, because this layer describes the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connection for bit transmission and to and from a network device. Okay. So these are the OSI model. I'm sorry, I think I. So let's proceed with our TCP model. So in our TCP model, as you can see here, okay, as you can see, this TCP model is only consists of 4 layers. Okay, we have only the network access, the network layer, network access layer, the network layer, transport layer, and the application layer. This network layer is we can say it's internet. We can change it to internet layer. Okay, because maybe you will be confused about because we have already the network here, and then why we'll put a network again here. It's internet layer actually. So internet, we call it also network. Okay, then so we will proceed with the application layer first. This layer represents the data to the user plus encoding and dialogue control. So the next one is the transport layer. The third layer supports communication between the diverse devices across diverse network. The next one is the internet layer, or the layer 2, or the network layer, determines the best part through the network. And lastly is the network access layer, controls the hardware devices and media that make up the network. Okay, so let's proceed. Okay, so we have here let me just do like this. So we have here the OSI model versus TCP or IP model comparison. So OSI lost out to TCP or IP as the protocol suite of the internet. The TCP and IP model is mapped to the OSI model. So TCP or IP is the protocol used today, but OSI model is often used to describe network communication. So the application layer of the TCP model is consisting of the application, presentation, and session layers of the OSI model. Then both layers have their equivalent transport layer. The network layer in the TCP and IP model is equivalent to the network layer of the OSI. And the network access layer of the TCP model is equivalent to the data link and physical layers of the OSI model. And that's it. Okay. I'm gonna open the topology or the save one, the save activities that I have then for topologies. Okay, so actually I'm gonna open this one first. This is the first laboratory that I have done. So let's proceed with the as I have told you earlier, I'm gonna show you the what we call this one. That's things that I have done so far. So I have saved all the laboratory. Then I'm gonna walk you through so that you will know, or you will also familiarize the contents, because the first laboratory is like only familiarizing what is inside, or what are the things inside the Cisco packet tracer. So here we have here the network devices, okay, which is consist of routers. As you can see, there's a lot of options here for routers. Okay, if you're gonna want, if you want to use a router, you want it, just click it and then drag it there. Okay. And then next is the switch. So also you have a lot of options here for your switch. Again, if you want to use a switch, you have to click and then drag it there. Okay. And then we have this hub, which is this two, this coaxial and this other one. I didn't get able to use that one yet, or I don't get a chance yet to use this. But that's one we did use this one for our laboratories. Okay, and here we have also this the wireless devices. Okay, Also, no, I did not also get the chance to use this. Maybe in the later, I mean, the next, the next modules. So as well as the security and there's one emulation. Okay, so let's proceed with our end devices. We have PC, laptop, server, here, printer, IP phone. It's here all okay. So if you want to use this one, we will just again click and drag it there. Okay, and this one, no, not yet also, or I did not also use this or get any chance to use these things. Okay, and that's in this, but this one, it's very important for our connection. Okay, from the name itself, connections. Okay, so but we usually use only this one, this copper straight, and this sorry, in this copper crossover, and we can also use this one. This is automatic. Okay, so I'm gonna show you. Okay, how, no, I just, just a like a brief only of how it would be or looks like if you're gonna use the automatic. So if you're gonna use the automatic, you just click it, okay, and drag it there. But if you're gonna use or click, you want to use the particular connection, like this one. See, you have to click the fast Ethernet and then click again the fast Ethernet. Okay, that would be. So in here also, this is for the connection between the switch. Okay, this cross. Oh, then you have to do like that again, and then again. Okay, let's delete this one and we'll use automatic. So no hassle for automatic. That's it. Okay, yeah, this is automatic. We'll use also the, not the particular one, which is the of yeah, the copper straight through. Okay, that's it. That's it. That's all. And that's the main purpose or the use of the connections. So, and you, as you can see here as well, earlier, you can see the amber light here. It means that, the it's still under process, because you can see that it's under process or it's not yet connected, but it's there already. I think it's like, yeah, maybe I could use the under process. Okay, so now it turns green. So it means that the connections, they are okay, it's perfect. Okay, so I'm gonna close this one and then I'm gonna show you also the topologies. Okay, as I we will proceed with our topologies. I'm gonna show you what it looks like. Okay, especially this bus topology. As we mentioned, that bus topology, it's like, connected with a single cable. So let's show you how it looks like. I'm gonna, let's just share it with you. Okay, so this is our topology, bus topology. Okay, this is only like, it's all amber, amber, amber. Okay, you have a lot of devices. You have PC, you have laptops, you have printers, but it's only a straight line here or straight connection only. There is no, like, there is no, it's like a simple one, simple connection. That's, they call it bus topology. One cable only like this. It's not so complicated connection. Okay, that is our topology. Okay, and then again, no, we will proceed with our star or ring topology. Let's proceed with the ring topology. Okay, let me again share with you the ring topology. Okay, so this is our ring topology look like. It's not actually, maybe you are thinking about a perfect ring or perfect circle. No, it's not. You cannot. Maybe in reality, but this is, one more thing. It should be, when you are doing these things, this past topology, you have to use the simulation, not the real times. It should be put on simulation. So this is our ring topology. Okay, it's like circle. Yeah, it should be round. So it's not locked like it, but it's see the switch. It's all here, and then the devices it's just outside connected to them. Yeah, that's the ring topology. Okay, so now it's still amber. Let's proceed now to our next, which is next topology is the star topology. So this is our star topology. So as you can see in our, I mean, as you have noticed, sorry, 1 minute, I'm gonna just share with you first because I know you couldn't, it will not show, I'm using again, of course, our friend Zoom to do this kind of recording. So anyway, as you can notice earlier, the bus topology in the ring topology, we are not using any hub. Okay, only the switches and the end of devices. So but here we have to use the hub. If you are using hub, then it means that you're gonna use the topology, the star topology. Okay then. So here we have the hub and then these four switches connected to one hub. Okay, and then again this end devices being connected to our switches. Okay, so remember, if it's a star topology, you have to use the hub, one hub, to connect all networks. Okay, now we have to proceed with our mesh, the one that I have mentioned earlier, that it's like really for me it's complicated because there's a lot of connection at all. It's like a spider web. Okay, let me again share with you this mesh topology, what it looks like. So here it is. See, I told you it's a like a bit complicated. Yeah, it's not it's really is complicated. Yeah, as you can see it's like a spider web. It's really a spider web. So here, see, also notice that we don't have any hub here. We are only using the switches, but in the ring topology we are connecting it here, right? But in this mesh topology you can connect this switch to here, this to here, this to here, vice versa. You can connect it vice versa. That is the mesh topology. Okay, so I hope you understand. Okay, so lastly, as the hybrid. Let me open the hybrid topology. Let me So this is what I'm talking about, the hybrid. The hybrid is the combination uh, of two topologies. Okay. So we have here, this one is a bus topology because it's only a single one, single line or single cable, single line. Yeah, it's a simple one. But we use the hub. So meaning it is star topology. Yeah, here the hub, and then it's connected here connected all the switches and all the devices. So this is the hybrid looks like. You can use also, I think, yeah, you can use, so I told earlier, you can use also the bus topology with mesh topology, the star topology with ring topology. It's up to to your liking. It's up to your liking. So but this is it's like a simple connection. Okay, so yeah, this ends my presentation for my course project for IT 221.